In today's video, we are focusing on the electromagnetic spectrum, which is the complete range of electromagnetic waves that exist in nature, and we will explore both their sources and the effects they produce when they are absorbed by different materials. The very first thing you need to understand is that electromagnetic waves, which we often refer to as EM waves, are all transverse waves, meaning they oscillate in a direction that is perpendicular to the direction in which the energy they carry is being transferred. This oscillation is usually visualized as an up and down movement. When EM waves are traveling through a vacuum, such as space, they all travel at exactly the same speed, which is 3 times 10 raised to the power of 8 meters per second, or in other words, 300 million meters every second. However, when these waves pass through different materials or mediums, they slow down or speed up depending on the properties of those materials, particularly their density, and this change in speed is what often leads to a phenomenon called refraction, where the direction of the wave bends or shifts as it crosses from one medium into another. If we take a closer look at how electromagnetic waves are classified, we see that the electromagnetic spectrum is typically divided into 7 broad categories based on their wavelengths and frequencies, and even though these categories have names such as radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, they are not separate things but all part of a continuous range. What makes each type distinct is its wavelength and its frequency, and these two properties are inversely related, which means as the wavelength becomes longer, the frequency becomes lower, and as the wavelength becomes shorter, the frequency increases. As you read the spectrum from left to right, starting with radio waves, the frequency of the waves increases gradually while their wavelengths decrease, so we go from radio waves, which have extremely long wavelengths, sometimes measuring multiple kilometers, all the way to gamma rays, which have extremely short wavelengths of less than 1,000th of a nanometer. Human eyes are only capable of detecting a very small part of this vast spectrum, which is called visible light, and this tiny range of wavelengths gives us all the colors that we can perceive with our eyes. Now, one of the trickier parts of learning this topic is memorizing the exact order of the waves in the spectrum. A good strategy is to begin with visible light in the center and move outwards in both directions. If you struggle to remember the colors that make up visible light, you can use the acronym ROIGBIV, which stands for red, orange, yellow, green, blue, indigo, and violet. On the spectrum, infrared comes just before red and ultraviolet comes just after violet, which is a helpful way to remember their placement. Continuing outward from ultraviolet, you then encounter X-rays and gamma rays, and it is important to know that these 3 types, ultraviolet, X-rays, and gamma rays, are all classed as ionicing radiation, meaning they have enough energy to knock electrons out of atoms and potentially damage living cells. On the opposite end of the spectrum, before infrared, we have microwaves and radio waves, which are typically used in various forms of communication technologies, including mobile phones, television broadcasts, and satellite systems. Moving on to the origins of electromagnetic waves, the simple answer is that they come from many different sources and processes throughout the universe. You don't need to memorize every detail, but here are some useful examples to help build your understanding. Gamma rays can be produced through processes like radioactive decay, while visible light, ultraviolet radiation, and X-rays can all be emitted when electrons within atoms fall down from higher energy levels to lower ones, releasing energy in the form of EM waves. Additionally, the vibration of molecular bonds within materials can produce infrared radiation, so this type of wave is often emitted by warm objects, including our own bodies. Essentially, EM waves are being generated all around us all the time by a variety of mechanisms, both natural and artificial. Once emitted, these electromagnetic waves travel outward, often across vast distances, including through the vacuum of space where they do not require any medium to move through. When these waves eventually come into contact with a surface or material, a few different things can happen. The wave might be reflected off the surface, absorbed by the material, or transmitted through it depending on the properties of the material and the type of wave involved. Sometimes all 3 actions occur together to varying degrees. For example, one part of the wave might be reflected while another part gets absorbed and yet another portion could pass through. This interaction with materials is what determines how we see objects, how we detect heat, how medical imaging works, and much more. That brings us to the end of this lesson on the electromagnetic spectrum. Hopefully everything made sense and helped clarify this complex but fascinating topic. If you found the video helpful, please feel free to share it with friends or classmates, and we'll see you again very soon for the next lesson.